Alright, so now let's look at the derivative of cosine x using the graphing calculator. We want to do the same thing. We want to, at this time, we'll just put cosine x into y1. And so the calculator is already set up for us. We'll clear out the functions we had in there. And for y equals, we're going to put cosine x. The derivative of y1 is already set up for us in y2. We have already got the thick line. So we'll do a zoom 7, or at this point you could just hit graph because that window is already set up for you. Here is our cosine function. And here comes the derivative of cosine. So I'd like you to, pause the video for a minute or a few seconds and just try to make a guess as to what function you think that is. So if you guessed the opposite of sine x, a negative sine x, right? This is a sine graph reflected. So the derivative of the cosine x is equal to the negative sine x. And so this one we're going to leave the proof out for this class. It's a similar proof as the one that we did for sine x. And so now we have two derivatives. We've got the derivative of sine, which is cosine, and the derivative of cosine, which is the opposite of sine. And we'll use these along with the properties or rules that we've already learned, the product rule and the quotient rule, to take some more complicated derivatives. So the first one here, example 1, we're going to differentiate y equals e to the x sine x. So I know that dy dx is equal to the first times derivative of the second plus the second times derivative of the first. And I am writing this out the long way. You can, at this stage, write the first and literally write the derivative of the second. But since we're new at this, I want to make sure you're seeing all the steps. So we're going to have e to the x. The derivative of sine x is cosine x plus sine x times the derivative of e to the x, which is e to the x. And so as often as possible, I want you to factor out any common factors in these. So we're going to factor out the e to the x, and we get cosine x plus sine x. Now there is a trig substitution that says, a trig identity that says it's sine squared plus cosine squared is equal to 1, but these are not squared, so you can't make a substitution, so this is your derivative. Right? The next one, we're going to use the quotient rule. So f prime of x, so in this case I'm going to take the bottom, 1 minus cosine x, times the derivative of the numerator, times the derivative of the top. So I'm not going to write the derivative notation, I'm just going to do the derivative in my head. The derivative of cosine is negative sine. So the bottom times derivative of the top minus the top, which is 1 plus cosine x, times the derivative of the bottom. So the derivative of cosine is negative sine, but we want the opposite of the derivative of cosine. So the derivative of negative cosine is actually positive sine. All over the denominator squared. Right, so now we want to simplify. Distributing, we get negative sine x plus sine x cosine x. Then distributing a negative sign, we're going to get minus sine x, and then minus cosine x sine x. So distributing the numerator, I get negative sine x plus sine x cosine x, minus sine x cosine x. So the numerator cancels. I'm left with negative 2 sine x over 1 minus cosine x squared. So at this point, I'd like you to pause the video and try the next problem. It involves using, the next two problems. The first one involves using both the sum rule and the product rule. And then the second one involves the quotient rule. And what I'd like you to do is try to simplify as much as possible. Factor, cancel common factors. All right, so the first one, we're going to take the derivative of each factor. So d dx cosine x plus d dx of x sine x. So the derivative of cosine x is negative sine x plus the derivative of a product. So it's first times derivative of the second, which is cosine x, plus second, which is sine x, times derivative of the first, which is just 1. And the negative sine x and positive sine x cancel, so you get x cosine x is the derivative. Alright, let's look at the next one. I'm going to start by using the quotient rule. So it's the bottom, 1 plus cosine x, times derivative of the top, which is cosine x, minus top, sine x, times derivative of the bottom. So the derivative of 1 is 0, but the derivative of cosine is negative sine, all over the denominator squared. So my job is to simplify as much as possible. When I distribute, I get cosine x plus cosine squared x plus sine squared x, all over 1 plus cosine x squared. Now cosine x plus sine x is equal to 1. So I get cosine x plus 1 all over 1 plus cosine x squared. And now I can cancel one factor of 1 plus cosine x and get 1 over 1 plus cosine x. And here's your derivative. All right, let's look at the derivatives of the. So now we have the derivative of sine and cosine. Let's get the derivative of tangent and secant. And you're actually going to derive these as part of your practice, because you know the quotient rule, and you know that the tangent is equal to the sine over the cosine, and it's worth doing this on your own. Give it a try and see if you can get it right, or even get it close to right, using the quotient rule, and also making some trig substitutions. Alright, so we know that the derivative of tan is going to be the same thing as the derivative of the sine x over cosine x. This equals the bottom times derivative of the top minus top times derivative of the bottom, which would be negative sine x, all over the bottom squared, so cosine squared x. In the numerator, we get cosine squared x plus sine squared x all over cosine squared x. And so we can make our trig substitution, which is 1 over cosine squared x, which equals secant squared x. So the derivative of tan x is equal to secant squared x. So you've got another derivative to add to your list of derivative rules. All right. So I'd also like you to derive the secant. So again, pause the video and use the quotient rule to find the derivative of secant. It's the same thing as finding the derivative of 1 over the cosine. So d dx of 1 over cosine x equals the bottom times derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So this equals a positive sine x over cosine squared x. And on this one there's a little trick to the manipulation. I'm going to write sine x over cosine x times cosine x, which equals 1 over cosine x times sine x over cosine x, which equals secant x tan x. So the derivative of the secant is equal to secant x tan x. So we've got the derivative of sine, cosine, tangent. We've got the derivative of now of secant. The last two derivatives I'm just going to state here, but you should make a list. You should keep a running list of all derivatives. The derivative of cotan of x is actually equal to negative cosecant squared x. We're not going to. You can try to prove this one on your own by just exactly how we did this one. So if you're curious, I would love it if you tried that. And also the derivative of the cosecant x is equal to negative cosecant x cotan x. And I'd like you to prove that on your own too, using the quotient rule. Just like we derived the derivative for tan and secant, you can derive the derivative for cotan and cosecant.